Okay, today we're going to be talking about applications of geometric sequences, and there are a lot of them. Exponential growth is a geometric sequence. So they talk about a city population growing by 12% each year. That is growth factor of 1.12. If it's decaying by 12%, that ends up being 1 minus 0.12 or 0.88. Okay, let's do a couple examples with these. This will be a little bit quicker lesson. So we have the population of a city is 3,456,000 at the end of 2019. Okay, let's put the commas in there, make it a little clearer. Find the population at the end of 2021 if it is decreasing by 5%. So that's 3, 4, 5, 6. My common ratio is 0.95. So I'm multiplying here by 0.95. And I can just say to the second power because I'm doing it twice. If I was doing this, if this is year one, 2020 is two, this is three, three minus one is two, or I can just think of it as 2 years from what we'll call this as year zero. Sometimes we'll do things as years from, say, year zero, and we'll just call this initial or zero, and then we don't have to subtract one. Um, we simply do that calculation, and I don't feel like punching it into the calculator. It's going to show me the solution right here. They did actually multiply it twice instead of doing squared. You get the same result of 3,119,040. Very simple example. Okay, at the start of an experiment, there are 251 songbirds in a state park. Scientists observe that the population of these birds grow by 4% each year. Use an appropriate model to predict how many birds will be in the park after 8 years. Okay, so U sub n, again, at the beginning here, 251. After a full 8 years, it's growing by 1.04. We're going to do that to the eighth. Oops, that's not a very good eighth power. Let's make it an exponent. And we grab a calculator. Again, I'm not using 8 minus 1 because I believe this is a year zero type of problem. This is not a U sub 1 here. My 251 is a U sub 0. And we get U sub 8 equals 343.51. So we're going to round that up to 344 birds. You can't have 0.5 birds. After 100 years, I just changed the exponent to 100. And I end up with 12,676.7. So I'm going to make it 677. Gonna double check that they agree with my, yep. Oh, they rounded to three significant digits, which three digits. We'll get to significant digits. Don't worry about the rounding for now. Growth and decay in chemistry. The half-life. Half-life problems are important to have a kind of a clue of. The half-life of carbon-14 is 5,700 years. How long it takes for half the amount of carbon-14 present in a sample to decay. Sample initially contains 127 grams of carbon-14. How much will be left after 2280 years? So I have a feeling 2,200 is going to be a multiple of 5,700? It's 4. So this is the fourth term in the sequence. So again, 127 is the 0th term. That's what I start with. I am getting half every time, and this is going to be to the fourth power. There's another little trick you can do. The number of years divided by the actual half-life. If it's not a whole number, that might be helpful. But in the terms of geometric sequences, it probably is going to be a whole number. And we have U sub 4 equaling 7.94 grams. And we can round that off. Growth and decay of salaries. Unfortunately, sometimes salaries do decay. That's very unfortunate sometimes. So a British company offers an employee a salary that starts at 45,000 GBP, which is, I'm not sure, pounds sterling is often what it's called, but 45,000 and increases by 5 years after employment. So calculate the annual salary after working for increases by 5% for 7 years. Give it to the nearest pound. 45,000, 1.05 to the seventh. Okay, then calculate the total money earned. That, okay, well, I guess we can calculate the first one. That's going to be a series. So their salary, wow, that's increased by a lot. 72,060. Oops, I did 1.07. 63,000. That's probably more believable. 63,320. Um, Calculate the amount earned for the company in the 7 years. Now I'm going to use the sum formula, which if you remember was U sub 1 times um oh wait, no. This should actually probably be to the sixth because you're going to get 45,000 your first year, I think. Nope, they did the seventh. That's essentially your 8th year salary. Probably is really your 8th year salary. But U sub 1, they are going to, yeah, they're not doing anything. Okay, they're not doing what I thought they were going to do. I think they've misphrased this. But S sub n, let's line this up a little bit different. There we go. Is r to the n minus 1 over r minus 1. Make that a meter r, not an n. So 45,000 is my first year. 1.05 to the seventh minus 1 over 1.05 minus 1. And I stick that into a calculator. And I get 366,390. That's how much they make in their first 7 years. Hence, determine whether the worker would earn more money if they accept a job for 7 years that offers 50,000 annual increases of 2%. So we're going to try this one. I think this one might be less, but it's hard to know because it starts higher. It probably will not be making as much in 7 years, but it might make more in total. We'll see. So might depend on how long you're planning on staying at a company, which what you would want to do with that. And actually, yes, this is higher, even though I'm sure that U7 would be less with the higher percentage. In fact, we'll just do that. Yeah, they're only making 57,000 in that seventh year. But because they made 5,000 more the first year and close to that the second year and the third year, it didn't compensate quite as much by the last year. Okay, that is the end of applications of arithmetic or geometric sequence and series.